long-forgotten art of ancient master craftsmen invokes in many a feeling that such art is now a thing of the past. While studying their artifacts, we admire the honed skills of their hands that endowed each object, no matter how commonplace, with a distinctive shape and appearance. The originality of each product was due to both their being handcrafted and the fact that the creator clearly put heart and soul into the work. Sadly, some crafts have long vanished. Others have, in time, become obsolete or have been replaced by mass production. However, there are still some people committed to preserving or bringing to life very old manufacturing procedures. Take a walk with us down the twisty, demanding yet fascinating road of manufacturing a replica of a medieval sword, with master swordsmith Richard Kasder as your guide. For this work, his inspiration was a weapon used in the 9th and 10th centuries in northern and central Europe. Our aim is not to create an exact copy of the original, rather to demonstrate the rigours and the beauty of this craft. The material chosen for the blade comes from the surviving fittings of an old farm carriage, processed 140 years ago. The properties of this material make it best suited for the process of forging. It is highly malleable and welds well in the forge. By welding the individual strips one by one, we gradually build the foundation of our sword. The quality of the material before forging is determined by a quenching test. A sample of the metal is quenched in water and broken in two afterwards. It is now possible to optically establish the structure for the hardening of the material. At this moment, it is the feel and experience of the swordsmith that enable him to separate carbon steel for the blade from iron for the guard and pommel. On the left, you can see the rough structure of soft, carbon-free iron. On the right, the grey and fine structure of carbon steel. The actual manufacturing of the sword starts by forging the blade from medium carbon steel chosen in the previous test, which best fits our purpose. We start by hammering out the material until it's flat, thus preparing the initial form. Here we are greatly helped by a compressed air hammer, an invaluable aid in the rough hammering work. We start forging the blade by defining the part of the material from which the future shape of the tang will gradually be drawn out. The tang will later be used to hold the hilt. This is where the exacting and hard work of a swordsmith begins, involving much repeated heating of the material to the forging temperature and many, many hammer blows. blade's profile is hammered in the direction away from the tank. We are shaping the diamond cross-section, leaving an area for the fuller to be made in the next stage. Free forging is basically the intentional relocating of material, which means that every single blow of the hammer has a purpose. The swordsmith knows exactly in which direction and at which angle the hammer must be driven in order to achieve the desired shape and length of the hot steel. Now let's look at some of the drawings to see what happens as the material is being shaped and at which angle the swordsmith strikes with the hammer. The first picture shows the angle of the hammer, which imparts a diamond shape on the material and spreads it out wide. The side view illustrates how the hammer's edge pushes the hot metal forwards, thus extending the blade lengthwise. The next picture shows an imprint of the hammer in the material. The top view reveals the changes made through hammering, and the arrows indicate the direction of the metal flow. We have finished the rough profile of the blade, and now it is time to make the fuller. Here the hammer and anvil alone will not do. We also need a forming tool, which is basically a forming die. Its working faces have the shape of the fuller, and the blade is forged from both sides at the same time. It should be noted that the traditional method of forging the fuller cannot be replaced by modern technology, such as milling, both for historical and practical reasons. Let's take a look to appreciate why traditional methods are irreplaceable. By forging, we've imparted a diamond shape on the blade through forming the surface of the material. However, the whole structure of the metal has also changed. While the external layers get denser and become harder, the inside, the core, is softer and therefore more flexible. A cross-section through the blade would look something like this. Using a milling machine would disrupt the structure of the material and the compact nature of the blade with an adverse effect on the resulting quality. When forging is employed, the core adapts to the shape of the surface, and the individual layers remain intact.